I will give this, or how I will be able to change to you? Anyone say? Hello? Anyone can respond?
Sir, you can send it to the CR.
Share. It will automatically go to your laptop.
No, sir.
Send it in
You
Google
could,
Classroom.
yeah, you could send it to the Google Classroom.
Google Class. So I will be required to change it to the Google Class. Under that situation,
Yes, sir.
you will be able to get this topic. Right? You see, yesterday I have talked at random something. At random, I had talked that concrete. Now, before that, again, I want to spend some time. Right? So, in this syllabus, you will be required to learn both RCC design as well as steel design as well as pre-stressed concrete design. Right? Now, here I am giving some idea about the reinforced concrete design. What are the things will be required? And similarly, you will be required to give something about the steel structure design, how to design it. Hello? So yesterday I told you how we arrived at concrete. How we will arrive the concrete. Now see, it is the three materials, binding materials. Somebody yesterday told me, a day before yesterday told me that binding materials, sand and coarse aggregate, together with water. And when you add the water, see, before adding water, they are individual, they are dry. They are after adding water, you are to mix it. You have to mix it properly. If it is hand mixed, then it will be hand. If it is machine mixed, then it will be in mixed. And during the time of mixing, it should get a position which is called plastic formation. That means there should be some flowability. There should be some flowability. At this moment, it is not having any strength. It is not having any strength. But remember, this concrete we require for getting strength for construction of our structure, whatever may be the structure. Say it is maybe beam, it may be column, it may be slab, it may be foundation, whatever it may be. Is it audible for all of you? Hello? Anyone respond? Is it audible for all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Thank you, thank you. Many of you are responding me. That means I am not a bad teacher. Or many of you responding me, that means I am not a bad teacher, if not good teacher. Anyway, now see here, this type of concrete is called plain concrete. Why it is called plain concrete? It is simple. After mixing the three ingredients, with water, and getting a plastic formation, it is a plain concrete. Now, when it is casted in the wood and it is allowed to cure, it becomes a plain concrete particle. Plain concrete particle. Now, problem is, in case of plain concrete, problem is that we will get some strength, but it is not that algebraic addition of the strength. See, if you see the sand, do you expect it any strength? Anyone respond? Sand, individually, do you expect any strength? Anyone?
No, sir.
Like cement, similar, sand and cement are similar. Sand and cement are similar. So individually, it is not having any strength. Similarly, but when you mix it with water and allow to cure, and after getting 20 in this tank, you will get some strength. You will get some strength. Now, this concrete, whatever we got, we will get some strength. What type of strength we will get? We will get compressive strength. We will get tensile strength. We will get torsional strength. Compression strength is when do anybody tell me, do you see my hand, two hand? Do anybody saw my two hands? Anyone?
No, sir.
No. Okay, so I cannot show it. Okay. Now, because of this, what happened is concrete. You had some test you had done in concrete laboratory, probably. I don't know in last semester whether you had got that scope or not. It is strong for compression. It is strong for compression, but it is not strong for tension. Similarly, it is not for torsion. So, if we want to construct our structure simply with the help of concrete, as your direct load goes on increasing, your size of the concrete structure has to be increased. Ultimately, a situation may come that member size becomes impossible to accommodate. Say, for our residential building, if we then the depth of the beam required may be 1.8 meter. Size of the column may be 1.8 meter by 1.8 meter, which is not at all practically possible. Okay, so to avoid, we require some materials. To avoid that some materials, we require some. Now that material we will introduce inside the concrete. We will introduce inside the concrete so that it will be able to resist. It will be able to resist the additional is coming on the member, particularly with respect to tension. How tension is going to occur? That is the problem. So again, I am talking you in your strength of materials or applied mechanics, you have studied the bending stress distribution and distribution. In bending stress distribution, you had came across one expression, capital M divided by capital I is equal to capital E divided by capital R is equal to small f divided by capital small y. This expression you are supposed to get. Can you tell me, anyone? To follow, capital M divided by I is equal to small f divided by y is equal to capital E divided by capital R. So that this type of expressions you had got or not? If not, you say no. Huh? Anyone? Yes. Yes.
We got, sir.
Very good. Remember, this is the most strongest instrument for survival of forest engineer. This is the most strong equipment for survival of a civil engineer, particularly structural engineer. M by I is equal to by Y is equal to E by R. Now here it is F. F is bending stress. Now because of this bending stress, where it is coming, so it will come normally in case of a beam. Normally, in case of a beam is supported at the two ends, some type of supporting element. So, if there is no connection between the beam and the column, then that particular beam is called simply supported beam. This you know. And because of the load acting there, self weight as well as some external load, maximum bending moment will arises. And if the load is acting throughout the span uniformly, then maximum bending moment will occur at the midspan, which is WL square by A. And we will get the stress. And if you see the stress F with respect to depth of the beam, with respect to depth of the beam, the stress F on some part below some point of the depth is tension in nature, and on some part above the some point it is compression. And that particular point here, that also you have learned, is called neutral point, neutral axis, neutral layer. If we in a cross section we want to demarcate, in cross section you will get a point, so that will be called neutral point. And through that particular point, if you draw an axis along the longitudinal direction of the member, it will be along neutral axis, neutral axis in longitudinal direction. And if you draw another line in breadthwise along that point, that is the neutral axis along breadthwise direction. Notice at this neutral axis, there will not be any stress. Stress is zero. And since stress is zero, do you expect any strain? Anybody? If there is no any stress, whether there will be any strain or not?
No.
No.
There will not be any strain.
No, sir.
So at the neutral layer or at neutral point, this is the most important character. The strain and stress as well as it is zero. Okay. Now, with respect to our that neutral axis, the upper part is subjected to compression. So no problem. Upper part is subjected to compression. If the beam is very concrete beam, simple concrete beam, nothing is there inside, it will be subjected to compression, so it will be safe, no failure. But a bottom part is subjected to tension. Since bottom part is subjected to tension, concrete is weak in tension. And if you see, according to IS code, the tensile strength of concrete, plain concrete, is hardly 10% of the compression strength. If compressive strength of a concrete at the end of 28 days is 30 Newton per millimeter square, then tensile stress is only 3 Newton per millimeter square. So 3 Newton per millimeter square is useless. So whatever stress is going to induce, taking by using that expression M by I is equal to F by Y is equal to M by R, that will be tremendously high. So that stress is to be resisted by the concrete. So under that situation, we will have to increase the height of the inertia. So if we have to increase the moment of inertia, then we will have to increase the member size, which is not practically possible. So to compromise this, what is done? In the tension zone, some type of materials are introduced, which are having resistance for strong resistance for tension. Strong resistance for tension. And now when these strong resisting capable elements are utilized inside this concrete, and together it becomes a new material. So that new material is called RCC, reinforced cement concrete. Okay. So main purpose for use of reinforcement is to increase the tensile strength of the member constructed of concrete. This is the main thing. Okay. So this you will get, I will give you later. Okay. So I am reading plain concrete has very low tensile strength for proper use of concrete subjected to tension. Some arrangements should be made to increase the tensile strength. Okay. Okay. So ultimately what happened? We got plain concrete and reinforcement. There must be some advantage and disadvantage. Now, first, let us see advantage of reinforced concrete. See, so reinforced cement concrete has sufficient good compressive and good tensile strength. Now, see what I told you. The reinforcements are utilized to increase the strength in tension zone. Increase the tension zone, because in tension zone the concrete is unable to resist the tension. So if in tension zone we introduce some member which is called reinforced. And the meaning of the reinforcement, we introduce something which is giving another force. Some force we had already. Because of introduction of this new material, we are getting another magnitude of force. We are getting another magnitude of force. So this magnitude of force, since we are getting, that's why this magnitude of force we have got because of reinforcement, and that's why it is called reinforced concrete. Okay. So reinforced concrete structures are durable. Reinforced concrete structures are durable. If designed and constructed properly, they may last up to or more than 100 years. Why it is durable? Why it is durable? Can have any idea? Reinforced concrete is durable, which I am giving two words here again, with minimum maintenance. Any idea? Anyone? Any idea? No? Respond somebody? If no, no.
No, sir.
I do not want that you should sit idly in class. Also, I told you that I do not expect that you know everything. I expect that you have some knowledge before coming this class. So me. Well,
Sir,
that knowledge. You want to tell something?
due to added reinforcement, it can withstand more tension.
Due to?
Added reinforcement.
No. That is the main philosophy. That is the main philosophy. Now, our discussion was, it was more durable. It may give the lifetime and more than 100 years. I want to learn from you. I want to learn from you why it is more durable. Strength you had got. That answer I got. Okay. Why it is durable? Okay, very simple. Very simple. There is the external effect are simply, if we can say, the external approach due to atmosphere. Okay, so there are large chemistry, so that we do not require. Somebody from the chemistry, we got this answer that in concrete, the atmospheric effect is very less. But it is now is not correct. For concrete, it is correct, but for RCC, it is not correct. Previously, it was accepted correct, but now no, because the reinforced materials that we are going to utilize are steel. I think all of you know what is the bad effect of steel. What is the more susceptibility of the steel? Anyone?
Sir, it is high in elasticity.
Repeat.
High elastic.
Rusting.
High elastic.
High rusting. Yes. This is the rusting problem. This is the rusting problem. If you keep the steel, a bundle of steel rod, bundle of rod on atmosphere, say on your courtyard, if you keep for 2 years, you will see there are rusting. But steel is again having one good quality. If you same bundle of steel, if you keep in a pond, bottom of the water, after 3 years, 4 years, 5 years, you take it out, it will remain as it is. So these are the things, because when you are keeping on your courtyard, the rods are getting affected to change of climate. Sometimes rain, sometimes heat, sometimes cold. Because of the change of climate, change of temperature, there is something there, and that you have studied in your strength of materials. Temperature effect. Temperature effect or temperature stress. Sure, that will come. But if you keep under the water or under the ground, say at about 3 feet below, and after 10 years, if you remove it, you will see it will remain, because this will be at a constant atmospheric condition. So there is no scope of rusting. Okay. And then with other materials, see, we have to get some members of different size. Say, for your, if I talk about your 10 students, you want to construct something in your house, so your member size may be different. Member size may be different. But in case of other materials, it is not easy to get different size of the material. Particularly if you go for steel or wood. But in case of concrete, if you already know it, that this will be the size required, so you will be able to do it. That you will be able to do it, because why? At the green period, that means immediately after mixing the water, it is having moldable characteristic. Moldable characteristic is mold. It will take the shape of the mold. If your mold is, say, beam size, say breadth is 250, depth is 450, and length is, say, 5,000. If you pour the concrete there, it will get of that size, and after 3 days you can remove the mold, and you will get the size of the bird, 250 by 450 by 5,000. Okay, so that is the moldability. Again, you got it. Even in physics itself, you have studied ductility. Physics itself study, right? Ductility. And what is the ductility? Any idea? Brittle and ductile. Ductile, and another word is brittle.
Changes shape in tension.
Changes shape in tension. It is a property of ductility.
Yes, sir.
Very good, very good, very good. You are able to give the answer in a very common language, not in a complicated. Huh? Very good. We can change the element in tension. If we cannot change it, it will break it. Then it will become. Now the question is whether concrete is ductile or brittle. So this is another one disadvantage. Concrete is not ductile. Concrete is not ductile. Concrete is brittle. But due to use of the reinforcing steel, reinforcing element, we can recover. Due to use of this reinforcing element, but we can recover the ductility. We can minimize or reduce the brittleness. So this is the most important character, that after using reinforcement inside the concrete, again it becomes a new element. First it was concrete, and after that it was reinforcement. Concrete is almost brittle in nature, but it is almost ductile in nature. I should not say fully ductile, but almost ductile in nature. Then transportability. Transportability means the raw materials we can transfer from its source to the place of construction. We want to construct a building. So in the building there will be beam, column, slab, etc., etc. So if you are to construct at the factory and if you are to transport to the work site, it will be very much difficult. But in case of RCC, it is the advantage that to the work site we can transport the individual raw materials. That's why it is advantage in respect to transportability. Okay, then fire resistance. We cannot say it is fully fire resistive. We cannot say it's fully power resistive, but to some extent it is fire resistive. And concrete is fire resistive, but remember, steel is susceptible to fire. Susceptible to fire. If you burn concrete, it will not change anything. But inside the concrete, if some steel is there, then steel will try to melt. So RCC is not a, to some extent, but we can make it fire resistive, taking some system. So probably that part is also included in your syllabus. Okay. Then we will to count with seismic resistance. Seismic resistance, whether concrete or RCC, is seismic resistivity is there or not. If we want to say in the first instance, it is not seismic resistive. It is not seismic resistive. But with the help of use of some knowledge, with the help of some knowledge and with the help of use of some mechanism, we can make this structure seismic resistive. Remember, many people make mistakes. Seismic proof. No, we cannot make a structure seismic proof. We cannot even man-made. Even NASA's made structures are not seismic proof. Seismic resistive. It can resist. It can resist up to some distance. Now, what is this seismic resistivity? That I will spend one class for that. What is seismic force? How seismic force is coming? How seismic force is acting? That we will be able to know in some other class. Okay, so these few things you had got advantage. Now come, there must be where there are some advantage, there are some disadvantage also. Do you agree or not?
Yes, sir.
Yes, where there is advantage, there is some disadvantage also. No? Why? Huh? Why?
Nothing is perfect in the world.
Good. But you had studied Newton's third law, remember?
Yes, sir.
Yes, sir.
So equilibrium, there must be equilibrium. So if there is some advantage, there must be disadvantage. And you had already told that there is no perfect. There is nothing is perfect if it is man-made. Even in Nasar, everything is perfect. So it is that. Okay. So cement concrete structures are heavier than the other structure. So this is the most disadvantage with respect to concrete structure. This is the most disadvantage. This see self-weight of concrete is 25 kilonewton per meter cube. Okay, even for self-resistance of the structure, we require some larger size. But in case of if you will want to construct, say timber structure, the self-weight of timber is less. It will not be messy, but concrete is, that is the most disadvantage. Reinforced concrete structures needs lots of formwork. Say the concrete, after mixing, it becomes plastic. It is not taking its own shape. So to keep it shape, we require some formwork, shuttering. You have observed that it's shuttering. So another cost, another expense, which is not having return. Which is not having return. Okay, this we cannot avoid also. So this is another disadvantage. Then concrete takes time to attain this stage. See, if you construct a house of bamboo or timber, you will be able to use it within a month. But if you go for RCC, no, it will take some minimum time. It will take some minimum. So these are the few disadvantages. Now, if you see, compare it. So we are getting 3 disadvantages, but 9 advantages I mentioned. So ultimately, comparing this, what we will say, concrete is more advantageous or disadvantageous? Anyone? We are getting
Till we find the new solution.
okay. How much time I got? I took. How much time? Anybody saw your watch? Hello? If I stop here, will you feel bad?
No, sir.
If I
No,
stop here,
sir.
No, sir.
you tell me. If you dislike, I will continue. If you dislike, you continue.
We won't dislike, sir.
Okay, we'll meet other day. Huh? Thank you all.
Thank you, sir.
Okay.
Thank you, sir.
Okay, thank
Thank
you.
you, sir.
Thank you, sir. Thank you, sir.
Okay, okay.
Thank you.